Hello everybody, hope you're doing well. So we are in lab 5, it's not working lab, it's lab 5, and we're going to be looking at hypothesis testing. So I'm going to switch this up a little bit just so it looks a little bit nicer. But anywho, so before we get started with that, I'm going to go into what we looked at before. So remember from last week, we were looking at this particular example of how to get your z-score. And let's say you have your 5-year-old son who goes to the doctor's office for his annual checkup, and he weighs 45 pounds and 49 inches. And so the statistician wants to know how her son compares to other boys, his age, and she looks up the average height and the average weight for his age. And then she consults her unit normal table, the Z table. And what I did here is I provided an additional amount of information here. So instead of it being, in this case, this is actually incorrect. Hold on a second, because I wanted to switch it up just a little bit. Give me 1 second as I reorient things. That's the number I'm looking for. So I switched things so that it would reflect a lower z-score because I wanted to compare these two when it comes to the last question on part C. Question 3, part C, which is the last question on that part. And here we have a z-score of 0.465 and we have a z-score of 1.875. Now, as you remember from last week, what we do with these z-scores is you would find the difference between the overlap of this value from this value, and you would end up with this area right here. That is the area between the mean and the z-score. But that gives us a glimpse of what we should be understanding about this question. So it does ask what is the probability of selecting a score that falls between your z-score and the mean. But what does that really say about the information that we've collected? So here is where our z-score is, 1.875, which would round up to 1.88. Because remember from our z table, if we look up this number in our z table, or a standard norm of distribution z table, the 1.8 is right here, and that's the tenths place. That's this area right here. Give me a second as I reorient. Okay, this area right here is the tenths place, and this area right here is the hundredths place. And so you're tasked to find the hundredths place, and that is the area right here. This is the 0.08 to hundredths place in order to get a value of 1.88. And what we would do here is, if I just move this over here, we would see where this area intersects with this area, and it's right here, as you can see. And if I was to use this, maybe this would be helpful as well. And I would go, okay, this is 1.80. The hundredths place is 0. This is 1.81, and so on and so forth until I got to 1.88 right here. And this is where there is an intersection, and that's where we're going to get our value of 0.96995, which rounds up to be 0.97. So the area of z-scores that are less than this z-score is about 97%. So 97% of people or boys of his age are have lower weight, are lighter than this sun. So, or her sun, I should say. That's 97%. We take this 97% and we subtract it. 0.97 minus 0.5. That's where we're getting this. And we get 47%. 47%. And now we get to draw this area between here, right? Because this photograph right here, we had the original photo. I can't find it right now, but there was an original photo where it showed the area between. It was kind of misleading because really the z-score is way out over here. So we would like to visualize this and show that there is a lot of space between the mean, which is 0, and our z-score, which is 1.88. And if we were to color this in, here's how much space. And this is 47% of the area to the right of this distribution, to the right to the mean. And you could do the same thing with this value when it comes to height. And we would get a z-score of 0.6 or 465. And if I was to erase this, illustrations, 0.4, 0, 0.41, 2, 3, 4, and 5, and 6. So here's where it intersects right here. And right here. And then from here, 0.67724, that rounds up to be 0.68. So we have 0.68, which we see right here. And really, I probably should put this as a question mark because I haven't even gone to that section yet. But this will kind of be like the element of surprise in the class when we do it in class. All right. So we have 0.68 that we've found from the z-table. And then we just find the difference again, right here, 0.68 minus 0.50. And that would give us 0.18 or 18%. And so what can we say about this? Well, before we talk about what we can say about this, this would be the area. But yes, this is what we would write to be very precise about what this z-score means, or what this raw score converted into z-score means when it comes to percentages, probabilities, and percentiles. So after I did the calculations, that means the score is higher than 68% of the class, because this table right here represents values left of the z-score. So 68% of the class, our score has a value higher than 68% of the class, and this is in regards to height of our sun. And so this should not be class, but this should be of the population of sons of this age in the United States. But rests within approximately by the 18th percentile, or 18%. And so where in this 18th percentile? This is a very important question here, because we're in the 18th percentile, because that's what we found when we found the difference between our z-score, or to the left of our z-score, and the mean, the area to the left of the mean, which would give us the area between, and that's 18% right here. So we're at the 18th percentile. This red line right here is 18th percentile of the what? Where is our location? Are we in the higher end of the distribution, or are we at the lower end of the distribution? We're at the higher end, so we're above the average. So 18th percentile of the higher end of the distribution. Higher scores towards the, we have two things here. We have the body and we have the tail. Just as a simple illustration, if I was to draw like a dinosaur, right? And this is our Brachiosaurus. Or maybe this is a giraffe. Or perhaps this is a camel, right? And the camel, here's the body of the camel, right? And then we have the tail of it right here. And that's something that we talked about when it comes to distributions. We have the body and the tail as well. And so just keep that in mind as the location. You're expected to know in this course that there are two essential sections of the distribution. This represents where most of the distribution is, which is the body. And then the tails are the ends where the least amount of information is in the distribution. So in this case, we're closer towards the body area of the distribution. And the reason why we know this is we know that 50% of the scores are to the right of the mean and 50% are to the left of the mean. So if we are, let's say right here, and this represents 25%, I believe once you cross 25%, you're more towards the tail end of the distribution. I think it might be even subjective, but we'll just keep that as that. Maybe that will be our metric. But this is definitely, we can see this visually, that this is definitely within the body portion of this tail. And that's pretty much how we can more precisely answer this question here. Now, we can do the same thing with here, with this one, and this represents, I think, the weight. If, yeah, so this is the weight right here, 97%. And if we were to go back here, and this represents the 47th percentile. And it's also the higher end because we're at the right of the mean. And it looks like we're more towards the tail of the distribution. So hopefully this is helpful. This isn't really a requirement so much. I haven't seen it in the main lecture, but it does come up in your book. And I think there's a section mentioning percentiles. I think it's box 6.1 in your book in chapter 6.